Hello everyone, welcome to my channel Civil Quick Revision. As we all know that the PWD JE exam or Water Resource Assistant Engineer exam or JE exam and the Fishery exam has a huge vacancy. Okay, and the PWD JE is just around the corner. After prelims, I think exam will be conducted very soon. Okay, so this is the perfect time to boost your preparation with smart and focused revision. I am here to bringing you quick, clear and exam oriented content and DPPs for daily practice. So stay tuned and stay focused and let's crack the exam together. Okay, now let's start the session. Now coming to question number 1. What is asked in the first question? Flexural strength of concrete is determined as flexural strength of concrete. This is FCR. This is the flexural strength. The formula is given as FCR is equal to 0.7 root over FCK. FCK. Okay, we can write this flexural strength, or we can write it as bending tensile strength of concrete. Bending tensile strength of concrete, or we can write it as modulus of rupture of concrete. Modulus of rupture of concrete. So here the option B will be the correct answer. Modulus of rupture is the correct answer. Okay. As we all know that modulus of rupture, it is a measure of the tensile strength of a concrete beams or slab. Okay. Now coming to question number 2, concrete. What is concrete? Concrete is what? Good in tension, good in compression, or what? As we all know that if we apply load on a beam like this, the beam will bend like this. You see, in this upper portion, the materials will compress like this, and in the lower bottom portion, the material is giving stress in this direction. This is tensile force, and in the above it is a compressive force. So concrete is mainly good in compression, okay, and weak in tension. You already know this thing. So option B is the correct answer. Good in compression, weak in tension. These are very common question asked in the question, mainly for JE. Okay, you just remember this. Now coming to question number 3, the partial safety factor for concrete is what? 1.15, 1.95, 1.5 and 2. Answer is 1.5. And you remember here for steel, partial factor of safety is 1.15. Okay. Now coming to question number 4, in the limit state design of concrete structure, the strain distribution is assumed to be what? It's a linear, non-linear, parabolic or rectangular parabolic. As you all know that if we draw a beam section like this, these are the reinforcement. If I draw a beam like this is the stress diagram, which is rectangular and parabolic. Okay, this is stress diagram, and the strain diagram is linear. Okay, this is strain diagram. So option here A is the correct answer. For in limit state design of concrete structure, strain distribution is assumed to be linear. Okay. Question number 5. In a single reinforcement beam, if the permissible stress in concrete reaches earlier than permissible stress in steel, jodi beta beam section to ki hobo jodi udhise permissible stress of concrete jodi permissible stress in steel ke beshi hoi jay tetia amar ki hobo tar mane concrete to age fail hobo to hetu over reinforced section hobo tate ami kono warning e napam. Okay, in under reinforced section ami janu tate stress permissible stress in steel to hoy hetu kintu joldi tomar মানে বেছি হ'ব দেন কংক্ৰিটতছে তেতিয়া আমাৰ হেতু আন্ডাৰ ৰেইনফোৰ্স বুলি কম এতিয়া ফৰ ইন দিস কোৱেশ্চন পাৰমিসিবল স্ট্ৰেছ ইন কংক্ৰিট ইজ reaches earlier, okay, than the steel, so that is called over reinforced section. This is a very common question asked in the examination. You please practice this type of questions. Okay, now coming to question number 6, according to Whitney's theory, the maximum depth of concrete stress block in a balanced RCC beam section of depth is how much? Whitney's theories is the mainly ultimate load theory. Okay, Whitney's replaced the actual parabolic stress diagram with a rectangular stress diagram. Okay, such that the CG of both the diagram lie at the same point and the area are also equal. This is the theory of Whitney's. Okay, Whitney's given the depth of balanced RCC beam section is given as 0.53d. You just remember this. This is a theory type of questions. Now coming to question number 7, the standard deviation is proportional to what? One formula you have to remember this. Fn is equal to FCK plus 1.65 of standard deviation. This is mean compressive strength. This is mean compressive strength. This is, you already know that this is the characteristic strength of concrete, and this is the standard deviation. Standard deviation. Now in the question, standard deviation is proportional to what? This is mean strength. Okay, option D is the correct answer. You just remember this formula. Fm is equal to FCK plus 1.65 sigma, that is standard deviation. Now coming to question number 8, in a limit state design of a reinforced concrete structure, the value of limiting neutral axis depth factor, that maximum factor depend upon what? This is K. Okay, depend upon grade of concrete, or it's depend upon grade of steel, or it depend upon grade of concrete and steel both, or none of the above. Here this is limiting neutral depth factor is presented as XU limit. Okay, in this question XU limit is depend upon grade of concrete, grade of steel, grade of concrete and steel both, or none of the above. The formula of XU limit is 0.0035 divided by 0.0055 plus 0.87 f of y es into d. Okay, you can see from this formula XU limit is proportional to what? Only grade of steel. Okay, grade of steel, f of y represent grade of steel. That is asked in the question. You just remember this by seeing this relation. Now question number 9, a beam of 400 mm effective depth with a neutral axis constant. The value of lever arm is equal to, as you know that lever arm is equal to lever arm is equal to effective depth minus n by 3. Okay, n is equal to k into d, where k is the neutral axis constant, d is the effective depth. If we put the value, d is how much? 400 minus k is how much? 239 into 400 divided by 3. The option is 348 mm. Option here C is the correct answer. Here the options are shuffling. Here just see this, option C is the correct answer. As we know, lever arm is the perpendicular distance between the line of action of the coupling force forming compressive and tensile force in the reinforced section. Okay, I will discuss this in details when I teach you RCC in details. Now for the time being, you remember this lever arm formula. These are asked direct formula based question asked in your exam. Now question number 10, the factor of safety for steel as compared to concrete is how much? For factor of safety of steel is how much? 1.15, concrete is 1.5. Obviously this is lower. Okay, as compared to concrete is lower. Option C is the correct answer. Now question number 11, according to IS 456, number of grade of standard concrete mixes are what? Here option A is 3, B is 5, C is 6 and 7 is D is 7. Here for standard concrete mix, number of grade is 7. You just remember this. Okay, for ordinary grade of concrete, I think the option here is 3, number of grade is 3, but for standard concrete mix it is 7. Now coming to 12, in a RCC structure, the tension zone lies in the, you already know, this is tension zone lie in the bottom part. If I draw a section of beam like this, the above portion is compressive and the below is tensile. Okay, here question is the tension zone lie in the bottom of the section. Now question number 13. If sigma s is the stress, I think this is not stress in the bar, and tau b is the design bone stress, then the development length of the bar of a diameter phi is given by, as you all know, that development length LD is equal to phi sigma s for tau BD. You remember this formula? This question is asked many times in many competitive exam. So option B is the correct one. Okay, now question number 14. Development length is inversely proportional to what? You can see from this above formula is inversely proportional to this design bone stress. This one, option D is the correct one. Now coming to 15. In a doubly reinforcement section, the total reinforcement percentage of steel should not exceed how much? Maximum how much? In doubly reinforcement section. Okay, total reinforcement percentage of steel should not exceed, option C is the correct one, 8%. Okay, so in maximum compression reinforcement 4 is equal to 4% of gross area, and maximum tension stress of reinforcement is 4% of gross area, but in this question total reinforcement of the steel, so overall 8%. Okay, now question number 16. Maximum ratio of span to depth of a cantilever slab is how much? Span to depth of cantilever slab is the option C is the correct one. 7. You just remember this type of question are repetitively asked in the question. Just you practice question. Okay, remember the theory and practice this type of question. Now question number 17. Minimum percentage of steel in a RCC slab is how much? Actually 0.12% of BD and 0.15% of BD. For 0.12% of BD is for HYSD bar and 0.15 BD is for mild steel. Okay, in the question it is not mentioned which one for mild steel or HYSD bill, so option both are correct. Here I don't give the both option corrector, so you just remember both are correct. Okay, now question number 18. According to IS 456, the maximum reinforcement in a column is how much? Maximum reinforcement in a column is 6%. Okay, and minimum is 0.8%. Okay, you just remember this. Now question number 19. A compression member is termed as a column or stud if the ratio of its effective length by least lateral dimension, lateral L-E-T-R-A-L, lateral dimension, this is not T, lateral dimension is greater than 3. Option A is the correct one. Then we can say it is a column or stud. Okay, now coming to question number 20. Okay, I will show you. The diameter of longitudinal bar of RCC columns should never be less than how much? This 12 mm. Okay, for RCC column 12 mm is the minimum range of the column. It should not be less than this. Okay. Now question number 21. The limit of percentage P of a longitudinal reinforcement in a column is given by, as I have told you, 0.8 to 0.6%. Option C is the correct one. For 0.8 is the minimum percentage, and 6% is for the maximum percentage of the steel in column. Now coming to 22. The isolated section for two-way slab in a isolated spread footing is at how much? Isolated section of a two-way shear. This is the foundation from the top view. This is the column portion. Answer is, it is from D by 2, distance D by 2 from the face of the column. From the face of the column D by 2 distance what mane shear failure hobo boli kaise, two-way shear hobo boli kaise. From the face of the column D by 2 at D by 2 distance from the face of the column. So this is the correct answer. Now coming to 23. The foundation raised on which of the following? It is raised on base of the foundation, it is raised on subgrade, or it is raised on foundation, or it is both subgrade and foundation. So answer here B, D is the correct one, both subgrade and foundation of soil. Okay, now coming to 24. The purpose of reinforcement in pre-stressed concrete is what? To provide adequate bond stress, to resist tensile stresses, to impart initial compressive stress in concrete, or all of the above are correct. Option C is the correct one, to impart initial compressive stress in concrete. Okay, now coming to 25, free body diagram is what? Free body diagram is an isolated joint with only body force acting on it, or it is an isolated joint with internal force acting on it, or it is an isolated joint with all the internal and as well as external force acting with it. Option C is the correct one. Okay, free body diagram that internal and external force both lagi thakibo. Okay, now coming to 26, the beam shown is indeterminate of how much? Indeterminate of kiman hoy question apak khudise. Ami janu je degree of static determinacy is equal to degree of external indeterminacy plus degree of internal indeterminacy. Okay, degree of external indeterminacy is present like RE minus 3. RE is the total reaction. How much? What type of reaction are here? This is the roller support, so that's why only one reaction are there. This is one, this is one. In this fixed beam there is a 3 reaction we got. The total reaction how much? 1 2 3 4 5. So RE is the 5. Okay, this is the external reaction, minus 3 is the equilibrium reaction. So total is 2. Now DSI is how much? DSI is equal to 3C. There is no loop in this structure, so there is C is equal to 0, so DSI is also 0. So total DS is equal to DSC plus DSI, so 2 plus 0, that is 2. Option D is the correct answer. Now coming to question number 27, number of unknown internal force in each member of a rigid joint plane frame is given by, here there asks internal force in each member of a rigid jointed frame. If I draw a rigid jointed frame like this, they ask each member internal force in each member. If I see here, only three reaction are coming from, one vertical, one horizontal, and one moment is developed. Resisting moment is developed. So total 3 reaction are 3 internal reaction are developed in the rigid jointed frame. Option C is the correct answer. Okay, if they ask to tell member internal force in overall member, if they ask, then total number of forces will be 6, but for each member it is 3. Okay, now coming to 28, a truss containing J is a joint and M is a member will be a simple truss if what will be the equation? If M is the member, J is the joint. Okay, then we know the formula for simple truss is M is equal to 2J minus 3. You remember this for truss. Okay, option B is the correct answer. Now coming to 29, neglecting axial deformation. Okay, dk of a given figure is how much? Dk means degree of freedom, or you can say kinetic indeterminacy. This is kinematic indeterminacy or degree of freedom. dk is equal to, one formula is there for rigid jointed frame, 3j minus r plus m. Here we can neglect axial deformation. Okay, that's why we take this formula. 3 into j, how much? You see how many joints are present? 1 2 3 4 5 6 7 8 9 10 11 joints are there, minus reaction, how much external reactions are there? Here 3 2 external reactions are present. There is 1, and in slider 2 reaction. Total how much? 3 4 5 6 7 8 plus member how much? 1 2 3 4 5 6 7 8 9 10 11, total 11. So 33 minus 19, so we got the answer as 14. So option B is the correct answer. Okay, now question number 30. Which one of the following is not a force method? Here you can see Betty's method, column analogy method, unit load method, or Kani's method. Which one is not a force method? You remember this, Kani's method is not a force method. Now coming to 31, in a displacement method of a structural analysis, the basic unknown are what? Displacement, force, displacement and forces, none of the above. Displacement method আমি কি mainly মানে unknown to পাম হেতু হতিছে তাতে আমি displacement force পাও না displacement পাও না none of the above. Here only আমি displacement হে পাও. ঠিক আছে, question to this is also a common question asked in the exam. Now coming to 32, for a fixed beam, এটা fixed beam এর কথা কৈছে, or a fixed beam shown below, what will be the moment at A and B induced due to sinking of right support by del? এইটো কৈছে sink হৈ গৈছে মানে এনেকৈ তললৈ sink হৈ গৈছে তললৈ del আমাৰ deflection হৈছে মানে ইমান del মানে deflection হৈছে আৰু EI is the flexural rigidity of the beam. So moment at A and moment at B is how much? You just remember this. This type of questions are asked in the exam directly. Okay, that's why you just remember the moment, and moment at A is equal to 6 EI del by L square, and at moment B 6 EI del by L square. Both are same. So is the correct answer. Okay. Now coming to 33, an arc may be subjected to what? Shear force and truss, bending moment and shear force and axial force, bending moment and axial force. Here answer is shear force and truss, and also bending moment will also subjected here in an arc. One more thing you remember, for a linear arc it is subjected to normal thrust only, okay, and in a 3-hinge arch it is subjected to normal thrust, and radial shear and bending moment will not occur. Now coming to question number 34, a 3-hinge arch is generally hinged at its support, and here you can see a 3-hinge arch is generally hinged at its support. Because the 3-hinge arch eta generally support hinge hoi thake ba ami to eneke show koribo paru roller nidi ami hinge dekhabo paru asot aru kot thake at the crown at one quarter span or anywhere in the rib or none of the above. I mean ete thorila moi to crown ot diso ami anywhere dibo paru hinge to. Okay, option here C is the correct answer. Now question number 35, the shape of a suspended cable under its own weight. Under its own weight, the shape of suspended cable is ki hobo? Parabolic, circular, catenary, elliptical. Option C is the correct one, catenary. Now question number 36, a 3-hinge parabolic arc of span 20 meter. 3-hinge arch eta ase, there is span 2. Wait, I will give this as a hinge support. 20 meter koise and 4 meter rise hoy boli koise, 4 meter rise from the left support, and a concentrate load of 150 at a concentrate load ase kilonewton at a 4 meter from the left support. Calculate the vertical reaction and horizontal truss at support A. Support 8 amar horizontal truss or vertical reaction lage. Ami jodi A section to VA HA eneke show koru, duta reaction thibo hinjot PV HB, okay, and this is point C. Okay, now ami ki korim, summation of horizontal force 0 jodi koru to HC is equal to HB hoi jabo hoy na, so is equal to 0. Okay, because there is no external forces there, so this HA or HB to equate korile ami 0 pai jam, duita equal hoi pinai 0 hoi jabo. Now moment jodi moi beat moment at summation of moment at B is equal to 0 koru, then what ami ki koribo parim, then VA into 20 minus VA into 20 mi clockwise positive loisu, then a upor eta reaction ahibo nohoy 150 into how much, this is 4 left remaining 16 thakibo. Okay, how much, wait, 150 into ekhini iman thakibo yaloike into 16 minus kyo loisu, because why we take minus, because this is in the anti-clockwise direction. Okay, now from here VA is equal to how much, you can calculate it from here. We get it as this is 20. Okay, this is 20, we get it as 20 kilonewton, and VB is equal to how much, 150 minus 120, it's 30 kilonewton. Okay, now we got the value, the vertical reaction. Now we can calculate the horizontal reaction. Okay, I just remove this for now. You just pause the video and calculate it by yourself. Now calculate the horizontal reaction. So for that, moment at C is equal to 0. If we here moment at point C is equal to 0, so what will happen, VA into 10, VA into how much, half of this distance 10, VA into 10 minus HA into 4, this one HA into this distance 4 minus 150, this one anti-clockwise direction, minus into how much? Into 6, because this one is 4 and this is 6, total 10, midpoint is 10, so wait, into 10. Just a minute, my handwriting is not right now good. So from here you can see, as you know that the value of VA is how much? Wait, okay, this is equal to 0. It's equal to 0. Here HA into 4 plus 150 into 10 equal to VA into 10. VA is how much? VA was 120. 120 into 10, HA into 4 plus 150 into 10. If we calculate this, HA we will get as 75 kilonewton and VA is 120 kilonewton. You can see from this option VA is 120 and HA is 70. Option D is the correct answer. Okay. Now I remove this. Wait. If you have any doubt regarding any questions, you can join my Telegram channel and ask questions. Okay. And you will get this PDF in my Telegram channel. Now question number 37. A 3-inch parabolic arc of a length L and rise R is subjected to uniformly distributed load. The horizontal reaction at the support is how much? Okay, you see. If I draw a hinge like that, this is point C. This is point C. There is a uniform loading. Okay. This is the height H. Okay, this is the length L. There is a VA, VHA, VB, HB. But they ask horizontal reaction at the support. Okay, if you can calculate VA is equal to VB is equal to how much? This is W kilonewton per kilonewton meter. What you get? VA is equal to VB is equal to WL by 2. I think you all should you all know this. How can we get this? Okay, WL by 2. Okay, I assume you all know this. Now coming to summation of moment at point C is equal to 0. At point is equal to 0, then HA is equal HA into H plus W. This one W into how much? This is L. This is half of the portion is how much? L by 2 and into half L by 2 by 2. Okay, equal to VA into L by 2. Okay, এতিয়া আমি কি কৰিছো HA into height লৈছো at point C লৈকে, then আমি this UDL or পৰা W into L by 2 লৈছো half distance আৰু তাৰে আকৌ half লৈছো. Okay, because tar concentrating load to eta centroid থাকিব ন, that's why W into L by 2 আকৌ L by 2 half he karone loa hoise, because tar centroid to mane centroidal load hobo hetu ami calculate korisu equal to VA into L by 2 hobo. To yar pora jodi calculate kore apnalake pabo HA is equal to VA to kiman paisibo WL by 2, WL by 2 into L by 2. Okay, minus WL square by how much? This is 4 to 8 hobo. Tar mane aru eta H ase efale WL square by 4 minus WL square by 8. I have to H to efale loya hok, then how much you get? WL square by 8 H here moi H to risu but rise to R ase, so WL square by 8R. Okay, we can calculate or derive like this. You just remember for right now WL square by 8R is the horizontal reaction for 3-inch parabolic arc. Now coming to question number 38, it is shifting to this portion. You see, which one of the following type of losses of prestressing occur only in post-tensioning, not in pre-tensioning case. Etu koise post-tensioning ot kuntu prestress loss ami pao, not pre-tensioning ot na pao. Friction ne, creep of concrete ne, relaxation of stress in steel ne, elastic shortening. Option here A is the correct answer. Friction is the answer. Friction loss to post tensioning got thake. Now question number 39. As per IS 456/2000, a column is said to be short if ratio of effective length to corresponding lateral dimension to ki hobo. Short column karone ami less than 12 paum. So it mone rakhibo. Now coming to last question. A reinforced concrete column of size 400 by 400 have the diameter of longitudinal bar as 20 mm. Pitch of the lateral tie in this case for pitch calculation আমি তিনটা কথা মনে ৰাখিব লাগিব. First one is least lateral dimension to কিমান আমি পাইছো 400 mm. Second কি 16 times of এটো আমি smallest diameter of longitudinal bar lotrom. It is yet DA is longitudinal bar how much? 16 into how much? 20. You got this as 320 mm. And for pitch design calculation or 300 mm. If minimum we take it for pitch of lateral ties to lump. So minimum 300 is the minimum one, so this is the correct answer. So here I conclude my session. So thank you for watching. If you find this video helpful, don't forget to like, share and subscribe my channel. If you have any doubt, okay, you can join my Telegram channel for free notes and my DPPs. All the best for your exam. Keep revising and practicing. Okay, so thank you.